Let's talk about decorators. Decorators are special syntaxes of Python, and to understand it, we will first need to talk about declaring functions inside of functions. Let's consider the following example. In this case, we have first external function that is named getWrapped function that takes one argument, and we named it function as well, because that is what we want to pass there. We want to pass some function. It doesn't really matter for us which one. And then inside that function, we have declaration of a new function that is named wrapped. And this function has basically flexible arguments because we have both a variable argument list and keyword argument dictionary declared. And this allows us to take any combination of arguments for this function. And this function, the external one, just returns this function. So as you can see, we can take just the name of the function and return it. And this will pass the reference to this function outside of this function scope. Now let's talk about the internal function. In the internal function, we have three parts. So first of all, we have before and after messages. And then we have a call to the function that we have passed from here. And then finally, we return some result. This is the result of execution of this passed function. So what this wrapped function does, it takes its varg and key wargs and passes them directly to the function that we have passed here. Effectively, this is just a bypass function that does not do much on its own, except for adding these print before and after calls around the execution of the internal function. And this allows us to make such wrapping containers around other functions and other code. And here's why this is important. So let's, for example, make one wrapped sign from math library. So we will import math and we will wrap our sign function. Now we can just execute this and use our new defined symbol to call sign function. And as you can see, it executes correctly. So it gets the number 5, it passes it directly into math.sign and computes the number. And before and after, it indicates that it has been before and after execution of the sign function. This is a very convenient type of metaprogramming, and you can use it to get many useful things. For example, you can do timing, or you can do logging of arguments that are passed into other functions, or you can even hack around different functions and do some substitutions, a lot of things. You can do this with your own functions as well. For example, if you have my function that returns some value, and you just call it like this, you can see that it returns some value as expected. But more importantly, you can use the decorator syntax. The decorator syntax will apply this function to this function name and replace this function name with the result of this decorator. So when we do it like this, instead of getting directly my function 2, we get actually a decorator function. And we can call it. And as you can see, it now runs before and after from this wrapper, and it returns the value that the original function was intended to return. The syntax of decorator is basically a shortcut for doing something like this. So let's define the my function 3, and then we will do it like this. So we effectively call this getWrapped function, passing my function 3 as an argument, and save it back into the my function 3. And if we do it like this, you can see that now it does exactly the same thing as our wrapper. So it is just a shorthand convenient syntax for this. Okay, now let's discuss some useful decorators. For example, one frequently used formula is to define this timeIt decorator that will be usable to wrap any given function and compute the execution time of that function, so that you can later analyze how much time certain tasks or certain parts of your program take. There are even existing libraries that implement this exact decorator, so you don't have to implement your own. But for the sake of example, how to use decorator, this one is a good indication how to do this properly. And we have it declared. Now we can use it with some other function. And as you can see, this decorator correctly runs this function and returns some value, and then it performs analysis and reports that execution of this my function for took 2 times 10 to the minus 6 seconds, so basically 2 microseconds. Another beautiful property of decorators is that you can stack them, for example like this. And as you can see, it gets executing all the decorators and the function itself, and it prints out first the internal decorator and then the external decorator, because we have this call at the end of the decoration, and we have result of the function execution printed out. Another very important decorator for classes, beyond the class methods that we have already discussed, is property. For property decorator, we can use this kind of syntax. In this case, we have declared my class, and this my class has just one attribute. This is a property underscore val, and this is a private property that will contain some values that we have passed in the constructor. And at the same time, to read it, we create this function. This function just returns the value of that hidden variable. But because we have added this add property decorator, we can do it now in the following manner. And as you can see now, we can read this .val exactly the same as if it was just a normal variable property, not a function. So we do not have any brackets. In fact, if we were to try this, we would get a type error because int object is not callable. So this mc.val returns integer number. However, this approach only works for reading at the moment. If you were to assign this to new value, for example 4, you will get cannot set attribute error. And this is a great approach to enforce read-only properties in your classes. Of course, you have to make sure that your users respect the fact that you have put underscore in front of a private variable and will not try to access it directly. But in most cases, your users will understand that this is intentional and that going around this property being read-only might cause some problems with your class that are not expected. Another way to use property decorator in classes is to define read-writable attributes. For example, okay, so in this case we have defined a new my class which has age property, just as we had it before, and now we have also another age function. Please note that the names are exactly the same, and we have used this as decorator, age.setter. And this .setter means that this function will be called whenever somebody will try to assign a new value to this property. And it will get the new value as argument here, and then it will execute something. In our case, we do a simple sanity check and verifies that age cannot be less than 0. So we are not allowing negative ages. And as you can see, it works. So we have first created my class with default age of 5, and we printed that. Then we assigned 10, and we printed that, so it changed. We can verify that. And when we tried to assign -10, we received 0 as minimal possible age. Of course, you don't have to assign default value in this case. You can raise an error, for example, or maybe you just want to notify some other object that the value you are providing has changed. For example, if you are using this class as source of data for sub-user interface, it will be good to notify the changes of the data to underlying user interface functions.